Okay, hello everyone. This is Dr. Jaber. Today we will be finishing actually chapter 3. This is the second part of chapter 3. And in my previous recording, I recorded part 1 for chapter 3. So chapter 3 has two parts. One part which I covered last time, and I uploaded the slides for you and the recording. And now we will be covering the part 2 of the software design. All right, so let's get started here. There's something, okay, the whole lecture is going to be about something which is called UML, Unified Modeling Language. This is actually a language. This is a common language that is used for software design, mainly for object-oriented systems, actually. So it's a standard modeling language that is used for modeling the system. It helps in visualizing the system and defining what are the components and parts of the system, etc. Now, there are two parts and two different types of models in the UML. One of them is called the static models, and the second one is the dynamic models. So I will be covering here now. Let's talk about the static models. Static models, so those are they represent the structure of the system. So it shows what are the classes. I don't know if you guys are took the project-oriented class, because this is the UML fits very well actually for the object-oriented. So this one static model, you show the structure of the system. There is no dynamic. There is so the focus in what the system, what exists in the system, what are the things that goes into the system, the parts, etc. So some of the examples here: class diagram, object diagram, component diagram, and package diagram. I'll cover some of these. Starting with the class diagram, if you know object oriented, so things are represented by classes. And so mainly this one here is that you show the classes that exist for the system, and you show the relationships between them. So for this one here, there's an example, and this one is like for the student and registration, like a student wants to register a class or a course. Okay, so the student here is that, in the left hand side, the class student, it shows that it has some data and it has some methods, which are called functions also, you can call them. So the student has a student ID and name. Those are data variables. Okay, and then the enroll is the method that can be invoked into that class. And then the course is also the same. It has two data: course code and title. And then the method that is used is called add student. Moving on. Okay, so the second diagram is called the package diagram. Package diagram is putting things together actually. So like, I mean, here is that you the related classes that you package them together. Okay, so for example, here for the university application here, okay, or for the university package, okay, so you here we are including two classes. One of them is the student and one of them is the courses. So both of these classes are packaged together, and they form a package. Component diagram is again also this one. It shows the components or the modules of the system and the dependencies between them. So as you see here in this example, there is a registration system, which is what we call a model, and then module, and then also a database module or subsystem, etc., and then the notification service. So as you see here, these boxes here means those are the modules or components. But so the registration, okay, it depends on the database, so it cannot work by itself. It has to use the database. And then database also, it depends on notification service, because it wants to send some notifications, etc. Right, so that's so far I covered some of the examples of the static model, which it shows the models, which it shows the structure of the system. Now we will be covering the other part of modules in the UML language, unified modeling language. So this is called the dynamic. Dynamic here is shows like the actual behavior, like when the system runs, what happens. Okay, so that's mainly, I mean, what it is. So it shows the elements that are communicating with each other. So it captures the behavior, okay, the running thing kind of. So the example here, okay, I will be covering some of the examples of the dynamic modules: that use case diagram, sequence diagram, activity diagram, state machine diagram, and communication diagram. see those. Let's start with the use case diagram. Use case diagram is mainly it shows like how the external the external entities interact with the system. Okay, so like for example here we're showing an example here for the still I mean if for the application like a register or application like for registration for a university or a school. Okay, so how the externals interact with like the system is within this box here, which is called like the university system or the university application here. So the university application is used by a student and then is used by an instructor. The student is going to be enrolled in the class. These are the things that the student is going to do with the system, is going to enroll in the class and then is going submit an assignment, but grading the assignment is going to be the instructor is going to grade the assignment. So that's mainly showing the externals and the interaction with the actual system. What type of methods that these externals they invoke in the system. The second one is called the sequence diagram, and this is actually my favorite. I like this one, and we use it a lot in companies. Okay, so the sequence diagram here is that you are showing the communication between the objects of the system at runtime. And then, for example, here is that this is the still we're talking about the registration application. Okay, so you see, like we have a student is going to interact with the registration system, which is our application, and this is the database, right? Okay, so this is the student is going to invoke a method. Okay, by the way, with the sequence diagram, it's very important that as you see that things are communicated based in time. Okay, so first, okay, so the student is going to enroll in the class. Okay, enroll is a method within this this object. Okay, or this system, this class, for example. Okay, so enroll belongs to the registration subsystem. So the system is going to call this. Okay, the registration is going to enroll in the class, but then later on, see here, like these lines are not at the same. They are not at the same level here. Okay, so then after that, because this is based in time, so the first thing that you do, you enroll in the class and the student, and then after that, and then that the system is going to query the database because it's going to see if the class is there, or is there a class with the same information provided by the student. So a query it belongs to this database. If a database is a class, you will find the method is called a query. So this system is going to call this function or this method, which is called a query, which is going to return okay, yes, its confirmation is going okay, and then it's going to actually a query also is going query the system and is going to actually store the enroll the students and then update the database, and then when that database when this method finishes, it sends a kind of it calls a method which is called confirm, and then the confirm here, you see that after that there is a message that goes from the registration subsystem, which is called success. So mainly this is very interesting because it shows how things they flow in time. First of all, that's the student. This message goes from the student to the registration, and the second message goes from the system to the database, and then database it does the work. Okay, register the system, enroll the student in the class, and then return the confirm message. Okay, yes, it's confirmed, and then the system is gonna send back a message saying that yes, it is successfully enrolled in the class. So this is what is the sequence diagram. Now the second thing is the activity diagram. Activity diagram is mainly used, if you have a process or you have a flow, something that happens one, two, three, like I mean after each other. For example, like in here, okay, so this the process begins with the input, like check if a course is full. Here trying to like within the enroll actually, if you are enrolling, okay, so if the okay, let's put it this way. You remember in this previous diagram I said enroll is going to be a method, like the flow within this method is captured here like an activity things. Okay, so you start, okay, this is the execution starts say for enrollment, input the course selection. So this is this is where you the student enter the course, they'll select their course it wants to enter to register, and then after that, okay, the second step, okay, the second flow, it's a process. Okay, is the course full? If the course is full, it says yes, this means that reject, okay, the enrollment, you go this path. okay, this way. But if the class is not full, okay, so no here, so you enroll the student, and then the second step in the process, okay, you notify the student, and then that's the end of it. Okay, so this is a kind of a flow, 1, 2, 3. I mean, this one has to happen first. You check, you get the input, and then you check if the class is full. If it is not full, you enroll the students, and then you notify the students. So it's mainly the activity diagram is mainly used for the processes, and then for workflow. The fourth one, which is the state machine diagram. State machine diagram, like if, this is mainly like it captures the states and the moving from a state to another state. And then let me give you a good example about it. You know that the traffic light that used when people do drive in the road, there is a traffic light, like there is the color, the traffic light it is red, and then it becomes amber, okay, and then it becomes orange, like I mean, and then it becomes after that is green. So and then when we drive, we have if it is red we stop, if it is like amber we try to be slowly, and then if it is green we drive, okay, and we move forward. So moving from the state red, blue, sorry, orange to green. So this is models the system actually. So these are states of the system, and then to move from from one state of a system of the system to another state. This one there has to be there's an event, something has to happen. For example, like even in the traffic light, I mean between red and orange, there is a timer. Okay, they time it maybe for 3 seconds. When the timer expires, okay, this is an event now. Is going to move it to amber or orange, and then now from orange to green, there's also a timer, maybe 3 minutes, 3 seconds, sorry, 4 seconds, and then after that, when the timer, expires, okay, it moves to green. So here, for example, here we're showing an example like still, I mean that we are enrolling the students in the class. Okay, so this is the student to start the, this is for registration. The students wants to register in the university, for example. Okay, so the first thing that the student fills the form or the application, and then the application, like it's in the pending approval. It's still, it's pending. It's not accepted or not yet. Now, when the committee, like, or the university decide to approve the application, is going to be that, that the student registration becomes registered. The student becomes registered. Okay, and then after that, I mean, if the students if the wants to cancel the class, or the university, if they cancel, they cancel, then it goes to canceled here. So also while you are in here, that when the student, when it's pending approval, when you submitted the application here, okay, if the school, for example, if your high school GPA is not as what the department wants, or the university, and I mean requires. Okay, so at that point in time, the registration is going to be rejected, and your registration is going to be cancelled. Communication diagram, which is this is the last diagram with the communication. So this is here, it shows the interaction between the objects of the system. Let's take an example, and the messages between him here. So there is a student, and there is a registrar, and there is a course, and this is registrar also. So okay. Okay, so we have three objects: student, registrar, and course. So student, okay, sends a message to the registrar. It says okay, request enrollment. That's the message that goes from the student to the registrar. Now the registrar, okay, is going to send a message to the course, which is called update the roster. Okay, the roster here mainly is like the list. يعني قائمة الطلاب اللي مقبولين هنا. Now the second one is okay. Now the course, okay, is going to send a message to the registrar, which is says okay, yeah, confirmation update, and then again the registrar is going to send a message, which is this confirm enrollment. This is the message to send to the students. Okay, so this is mainly is the interactions between the systems here.